So this is the third of 3 acid and base lectures. We're going to look at neutralization and other acid-base indicators. We've been looking at entirely at universal indicator, but I want to show you that there's a bunch of other ones. So there's all kinds of things that react with acids and bases and show different colors. So we can use all kinds of them. So here I've got an example. Let me just show you the video of me making a red cabbage indicator. There's all kinds of other indicators. Rose petals, if you put them in different colors, I think they turn blue, but I can't remember if it's base or acid. Anyway, there's so many of them. Mood lipsticks, they work on a pH, that's why they change colors. Blueberries change color, red grapes, onions smell in one color, in one pH and don't smell in another pH. I'm going to make an indicator out of this red cabbage. So I'm going to grind up this red cabbage and turn it into a juice that will make it so that I can see whether something is an acid or a base. Okay, we got our nice purple red cabbage indicator, and I've got some lime juice here, which we've seen with the indicator paper. Let's just see what color it turns with some of that indicator. Ooh, that's a pretty nice red. Okay, this time let's try the baking soda with some of the red cabbage juice. See what that looks like. Ooh, nice fizzing. I like fizzing. Fizzing's fun. Ooh, and it's a very nice blue color. Oh my goodness. We'll let that sit for a while. Okay, this time we'll try the milk of magnesia. That should be also a base. Ooh, wow. There's some nice blue color. Oh, it's green. Oh, it's very green. The creaminess is from the magnesium hydroxide is not dissolved, but wow, it is very, very green. That is impressively green. So we end up with this red cabbage indicator, and I want to compare it with the universal indicator that we've been talking about before. So here's the universal indicator that we have been looking at before. We had a pH, the neutral was yellow, and then it's the reason universal indicator is so nice is because it's this perfect rainbow. They mix the 4 different indicators together so that it gives this beautiful rainbow. Anyway, there's a reason it's great. So the yellow is neutral, and the purple is strong base, and the red is the strong acid. But we can have that same range of colors with the red cabbage indicator. It's just that the colors are different because red cabbage has it's not designed to be a perfect indicator. It just happens to have a lot of really cool colors that change, a lot of chemicals that change with pH. So you notice red, dark red is a strong acid, similar to universal indicator, but then it goes from pink. Instead of getting more yellow, it turns more purple. So a nice straight purple is the same as neutral. And then they get bluer and bluer and greener and then they really, once we get to the strong bases, they are yellow and orange. So a moderately strong base is green, and then we go from blue to purple. is the neutral. So we got to switch our thinking a little bit and think neutral is purple, and green is base, and red or pink is acid. Okay, so that for the rest of this video, we're using the red cabbage indicator. So we got to switch our thinking. Purple is neutral. Okay, so what is actually happening when an acid gets mixed with a base? We're going to do neutralization. So you remember this hydronium ion is what gets added when when acids get added to water. The hydronium ion is what gets increased. We have more hydronium ion in the water when there's acids. Bases have more hydroxide ion, and here's our OH hydroxide ion is bases. But now, what if you take an acid and with hydronium ions, and then you add hydroxide ions? When these two get near each other, you notice we've got a positive charge and a negative charge. There's going to be a reaction, and that's what happens. A reaction happens, and it neutralizes. The hydroxide ion takes the hydrogen from the hydronium ion, and they both become water. Let's do that one more time. So here's the acid and the base. The base takes the hydrogen, the extra hydrogen from the acid, and we end up with two water molecules. Instead of an acid and base molecules, we end up with two water molecules, and it has been neutralized. We can turn something that is acidic neutral if we add enough base, and we'll see how that works. This time I've got a base, which is milk of magnesia, which we've got as green with this red cabbage indicator, and I want to try to add some of this vinegar, which we know is an acid. It's a pretty strong acid. I'm going to add the acid to my milk of magnesia and see if I can turn it purple like the neutral color. And what's kind of cool, oh my goodness, look at that. There's a big blob of purple in there where I squirted the acid, but let's see if it stays. Oh, it got purple, and then it kind of turned back to green once I mixed it up. So I think I need more acid. It's gotten less basic, but not all the way yet. Oh, that's pretty. Purple and green. Ooh, hey, the whole thing's purple. Whole thing is blue again. And back to green. Nice. This is going to take a lot of vinegar. Let's try more. So I'm going to add it big. We're going to go big, and see if we get anything. There we go. Purple. See if we can get to stay purple. There it is. I think that's it. I said that before though, didn't I? That might be it though. Oh, it's staying purple. It's staying purple, so we have gotten it to be neutral. Let's try blue again. Perfect. And blue. And probably green again. It's less green. No, it's still green. Anyway, we're going to need a lot. There we go. There. Okay. I swear to God, that's it, right? Okay, it is purple. It's staying purple. I think we did it. And notice that it's starting to clear up. I think we finally dissolved all that milk of magnesia. Ah, there we go. We did it. It is now neutral. We have neutralized the base, that milk of magnesia, with vinegar. We've added enough vinegar to neutralize the base. If you add acid to a base, it will become less basic. And at the end, I added enough acid to make it neutral. So if you add enough acid, and if you look at this, if we have a base here, and I add acid to it, that's going to pull it toward the acid direction, which means it's pulling it toward neutral or becoming less and less bases. So if I started at 10 and I add acid, if I add, it will become a 9. And if I add more acid, it'll become an 8. And if I add more acid, it will become a 7. And that will mean that it is neutral. Okay, so let's look at this one. So we know that this lime juice is an acid, both because I used the paper to be able, the universal indicator paper, and that turned pink, and I can neutralize it by adding a base. So I've got this thing, and now if you think about it, all of these things that you buy at the store, they call them antacids, and that just means anti-acid. So this is a base. I'm going to take some of this base and I'm going to drip it in here, and I'm going to see if I can get it to become less acidic and eventually become neutral. So what I'm looking for is it to become that purple color like the distilled water. It's getting purpler. It's getting purpler. But I have to add a lot of antacid. I have to add a lot of base to neutralize that strong lime juice, which is a pretty strong acid. Hey, there it's starting to turn a little bit purple. That's looking a lot more like my distilled water color. And I could double check it. Ooh, oh, it's very much like my distilled. There, that's the purple that I was looking for. In this case, we added base to an acid and it became less acidic. And eventually, I was able to get it to be neutral. So we started with an acid, which was pretty acidic down here at 2. I added a base that was about 10 or 11. The acid, as the base was added, it got more and more pink, and more purple. So it went from 2 to 3 to 4 to 5 to 6. And then eventually, as I kept on adding base, I eventually got it to become neutral. So in summary, if you add some acid to a base, it becomes less basic. If you add base to an acid, it becomes less acidic. See if that makes sense on the pH chart to you. And if you add just the right amount, it will become neutral. And that is neutralization. But I wanted to bring back the pH scale and remind you that it's 10, each step is 10 times. Each step is 10 times, you'd have to use 10 times more base. So if I had a 2, and let's 1, 2, 3, 4, 5, and if I wanted to neutralize it and use the exact same amount of the base as I have of acid, that'd be a good way to neutralize it. I'd have to take a 1, 2, 3, 4, 5. I'd have to use a 12 to neutralize it. And that would take the same amount of base to neutralize the same amount of acid. But if I was using a 10, I would need to use 100 times more. It makes a big difference. So, yeah. So those pH scale is a logarithmic scale, and which we are learning about with the coronavirus, that logarithmic scales increase dramatically. So that is neutralization. So let's just talk about pH balance, just the last thing. pH balance, basically all they're doing is they neutralize, if the soap happens to be overly basic, and remember our skin is right around neutral, so they will neutralize it so that it neutralize the cleanser or the shampoo so it is closer to whatever pH our skin is. That's pretty much all they do.